Having some trouble with your digital circuit? In this video, we'll show you how not to end up like this. We'll test the circuit we built earlier, and we'll show you some of the practical uses of the CADET II board. Hopefully, you don't end up with this headache.
Let's first do some testing of the circuit we built in video 2. Before you even get to lab, you should have some data tables drawn or printed out. It doesn't take long, and having them done beforehand will save you some time in lab. The second most important thing to do is to hook up power to your breadboard using the power sockets. This may go without saying, but you'll be surprised how often you can forget. I'm sure you'll do it at least once. To power our circuit, we'll use the 5-volt source and the ground on the CADET II board. The circuit we are using is a combinational circuit with multiple inputs, so the most appropriate tools for testing the circuit are the 8 logic switches and the logic probe. When we built our circuit, we designated nodes for each of the 4 inputs. That makes it easy to connect the inputs to the logic switches, and it helps us keep them straight. We'll use switches 1 through 4, which will correspond to inputs W through Z respectively. The output was set aside in the same way, so we can hook that up to the logic probe's input node. As for the VCC node on the probe, we can connect that to the voltage source via the power rail on our breadboard. To test the circuit, we simply go through every combination of switches and record our results. We could have also used the logic monitors to test the circuit. This is more appropriate when you have more than one output, but using the LEDs means you do not have to worry about connecting VCC to the probe. Yet another option we have for testing the output is the handheld probe. It works just about the same as the logic probe on the CADET II board, but along with VCC, we also have to connect the handheld probe to ground. The red lead should be connected to your power source, and the black lead should be connected to ground. This tool is great for troubleshooting because you can quickly test the state of all the nodes in order to examine the state of all the ICs in your circuit. When you're dealing with sequential circuits, like this counter, you will need to use the function generator as your clock. We suggest setting the frequency somewhere between 1 and 10 Hz. To accomplish this, set the center knob to 10 and adjust the left knob as you see fit so you can track the changes in your circuit. Make sure you use the TTL nodes on the function generator, or else your circuit will not work appropriately. As an alternative to the function generator, you can use the debounce push buttons to define your clock signal. When you use the push buttons, you need to connect a pull-up resistor to prevent a short to ground. Simply connect one end of a 1 kΩ resistor to the 5-volt source, and the other end to either a normally open or a normally closed node for one of the push buttons. Finally, connect a wire to the same node as the pull-up resistor to provide the signal to your circuit. If you need a rising edge signal, use the normally closed nodes, and if you need a falling edge signal, use the normally open nodes. That does it for video 3. We hope these videos have been informational, but as with anything, the best way to learn is to try it yourself. Thanks for watching, and good luck!
Technologic. Buy it, use it,